Hello, and welcome to this overview of compliance best practices for safety and transparency. My name is Larkin Ryder, and I'm responsible for compliance at Anthropic as part of Anthropic's security team and to serve our mission, which is to ensure transformative AI helps people and society to flourish. In this talk, I'll quickly describe Anthropic, the impact of AI on work, the ecosystem for large language models which drive AI-enabled features, the factors we must consider as governance, risk, and compliance professionals in the use of AI, and some resources we have available to help us do so. Finally, I'll give a quick overview of how Anthropic builds safety into our models. For those of you who are not familiar with Anthropic, we provide a large language model called Claude. You can go to claude.ai to try it out. I'm not going to discuss our AI in great detail in this talk, but I just wanted to mention it here so that you understand who I am and what perspective I'm bringing. We are incorporated at Anthropic as a public benefit corporation and accountable to a long-term benefit trust. We are a small company on the order of several hundreds of folks, but we are laser focused on our safety and public research. Our published research is highly cited. More than half of our company works on safety research in some form. I'll talk more about how that guides our product at the very end of this presentation. All right, so first let's talk about the impact of AI on our work. I, like you, work in a world today where AI is an increasingly large part of how I get my job done day to day. The data presented in this slide is from 2023, so here, so close to 2025, it's practically irrelevant. Things are moving so quickly, but it already showed a level of change coming to the work we do. The International Monetary Fund predicted in a recent report that AI will impact 40% of the jobs in the world today. So we can anticipate that the scope of this change in work will be significant. The Cloud Security Alliance has also done significant research showing how AI will be impacting the work done by security professionals. More broadly, some have compared to the way AI will reshape our working lives to the impact of the internet or even the Industrial Revolution. And we are only at the beginning of how far this work can go. AI systems are increasingly powerful, and the power is expected to continue improving. As total neural network capacity increases in the backdrop of growing compute, theretofore unseen new capabilities emerge into the network. You can see here in this graph, we show that with network size incrementally increasing, the range of human benchmarks, the networks on this range of human benchmarks, the networks go from completely failing at a task to very precipitously learning to succeed at the same task. And this trend has continued, each model that we develop showing more and more success on new emergent tasks. At Anthropic, as we think about how these increasing training and tuning capabilities come together, we are not expecting model capabilities to increase linearly. Instead, we expect to see models get 20 to 50 times better in the next few years. While this is great news for the eventual impact of large language models, but ensuring that the business, as the ensuing business demand increases, the stakes for everyone in the ecosystem get higher: vendors, customers, regulators, and end users. In addition, as we build more capable models at an exponential rate, we are also excited to develop a system of tools around that model and increase the value organizations can get. Some of the ways we do this are things like prompt caching, which is the ability to store prompts for lower cost, lower latency responses on the same corpus of text. The inclusion of retrieval agents in our systems, building the functionality for our model to call out and conduct many searches across a knowledge base and pull relevant data into a large, say, 200K context window. And then the increased ability in coding and API integrations allowed models to write scripts to execute additional functionalities. Of course, all this will rely on models providing increased trustworthiness, incorporating breakthroughs in alignment and interpretability research to increase that reliability. Multimodality will increase the range of data that LLMs can intake and increase its understanding of the world. This opens up whole new use cases. Finally, continuing to work with cloud partners such as Google Cloud and Amazon Web Services to train models on novel chips and deliver models at scale to organizations in a secure way where their data already exists. As GRC professionals, we have to consider all of these perspectives, ensure that businesses aren't assuming unknown or undue risk with the adoption of AI-based products and AI-based features that are being incorporated into existing products. So in order to ensure GRC professionals can fulfill those responsibilities, there's a need to understand the end-to-end ecosystem that allows large language models to come into service. And I think of that ecosystem as existing in three components. I think of model development, model hosting or deployment, and model use. And before applying governance, risk, and compliant practices, it's important to understand the full scope of this ecosystem. Let's start by understanding the first component of the ecosystem, model development. And certainly that's an area where I'm most familiar. This diagram shows a high-level representation of how Anthropic trains our Claude model. Large language models such as Claude need to be trained on text so that they can learn the patterns and connections between words. This training is important so that the model performs effectively and safely. To create the pre-trained language model, we start by curating a large-scale data set on which to pre-train the model. Both the quality and the size of this data set are integral to the eventual success of the model. The process of fine-tuning the pre-trained model is critical to its eventual ability to perform the more complex tasks at the highest levels of capability. But it also ensures that the model meets human expectations for helpfulness, harmlessness, and honesty. We refer to this as HHH, and we use this paradigm to establish a training regimen for Claude, bringing it into alignment with human values, desired use cases, and quality expectations. As part of fine-tuning, we also use an automated process called constitutional AI that helps to use automation to train the model into the HHH standards. And I'll discuss a little bit more about this at the end of my presentation. Not shown in this diagram, we are also evaluating the fine-tuned model to establish its level of capability on well-known benchmarks, and we're testing the model for safety. I'll pause here to note that one question I'm often asked is, what about the risk that my data will be used to train the model? I want to be ensured that when I'm sharing my data and I'm exposing it to the large language model, that the language model isn't then going to start consuming the data that's been shared. As this diagram shows, producing a large language model is a multi-stage iterative process that is completed in total before the model is ever deployed for use. It is also a process that has unique requirements for processing power, network bandwidth, and data storage. The end-to-end effort here may take weeks or even months, as this diagram doesn't show the weeks of safety testing and evaluation that the model is subjected to once the fine-tuning stage is completed. Once training is completed, the model weights are deployed for use, and generally, the environments we use to train our models are configured differently and are separate from the environments where we serve our models. So let's talk about the serving part of our ecosystem as our next topic. The next part of our ecosystem involves deploying the fine-tuned model to an appropriate hosting environment so that it can be safely used. Using the model involves sending prompts and receiving outputs, which we also refer to as responses or completions. Model deployments also require protections. Even after the exacting effort of the fine-tuning, there will still be some risk of harmful outputs and tool use. And so to mitigate this, a range of what we call trust and safety tools from a world-class trust and safety team should be deployed to monitor for harmful prompts and harmful outputs, with a team responding to those alerts and mitigating any scaled abuse. This is both to avoid the kinds of failures that get press headlines. After all, no one wants their bot to go viral for saying something awful, but also to prevent harm such as child sexualization materials, biorisks, weapon making, and other actor enablement harms. Output classification is an emerging area that will be applied to more powerful models. This monitoring is the combination of evaluating the relevant risks with empirical valuations and then designing systems to block relevant harms. This speaks to the value of highly effective evaluations, currently a need in the market that is not being addressed well yet. These teams, these trust and safety teams, also track scaled abuse and attempts to circumvent these safety systems across advanced threat actors. Anthropic hosts its own models, but also partners with Amazon Web Services and Google Cloud to allow customers to operate our cloud models in their own cloud-hosted operating environments. This deployment option allows governance, risk, and compliance teams to leverage their existing trust in cloud service providers they already have a relationship with, and to feel confident that their compliance benchmarks and prompt retention policy meet their company's needs. AWS Bedrock and Google Vertex services support this deployment paradigm. Finally, we talk about model use. This is the final component of the LLM ecosystem. Considerations for how models can be used are too varied to assess in a single presentation. The extent of the possibilities seem truly limitless. The abilities for LLMs to optimize every aspect of human interaction with language means that, as this diagram from the Cloud Security Alliance research shows, AI can support content generation, decision support, educational materials, and a myriad of other day-to-day interfaces such as help chats, research summarization, and email drafting. All right, so as GRC professionals, we're responsible for ensuring that AI technology is available safely and legally so that businesses can deploy it with confidence. This means that GRC professionals need to comprehensively consider the ways in which AI can pose a risk to those organizations. This is a daunting task. To start with, we know the ecosystem may distribute those concerns to the responsibility of multiple partners. As we discussed, there are 3 phases for this model ecosystem, and those 3 phases of the ecosystem, those 3 parts of the ecosystem can be assumed by a single organization or can be assumed by 3 different organizations. Any one organization could train, deploy, and use its own models. Or that organization could purchase an existing model from a partner, deploy it to a hosted infrastructure provided by a cloud service provider, and then either use that model or sell the use of that model to other users. This makes the shared responsibility model in the LLM ecosystem very hard to manage. As GRC professionals, we have to protect our business from this entire ecosystem of providers, of which we may be one. GRC process will need to vary depending on the organizations that are involved in the development, hosting, and use of model capabilities. For example, if we don't develop our own LLMs, but use LLMs provided by others, we need to be sure that those providers are responsible and consider the risks that their models pose. Model developers should be able to explain how they have systematically addressed concerns related to data poisoning, sensitive information exposure, bias, refusals, and hallucinations. They should evaluate how well their models are addressing each of these risks. Increasingly, there are standards and frameworks becoming available which attempt to identify the potential risks that we should consider when using LLMs. Our challenge is to ensure that we understand how the responsibilities are distributed for model development, model hosting, and model use, so that we can apply the insights from those standards appropriately and to the appropriate partner organizations. I'm going to provide some examples next of some resources we can leverage. First up, courtesy of the National Institute of Standards and Technologies, this generative AI profile helps us consider some of the serious risks related to the use of AI. It's part of the supporting material that's provided by NIST's AI Risk Management Framework. While the NIST AI RMF offers a general purpose risk management system for broadly useful technology, this profile is useful for considering some of the specific risks categories that should inform AI-related risk assessments for an organization. This list is expansive, taking into account societal harms as well as intra-organizational impacts of AI. Many of these concerns are contemplated by Anthropic's own responsible scaling policy, which I will encourage you to look up and read about on Anthropic's website. Next up, I wanted to share OWASP's top 10 for LLM applications. This wonderful diagram shows exactly where in the process of using an LLM application particular concerns may be introduced. I'm going to dive into a few specific areas of concern you should make sure that you understand here. One area of particular concern is bias. This is an aspect of what's denoted on this diagram as over-reliance. Bias impacts an organization when personnel do not take into account that bias in training data may be reflected in the responses provided by the model. To address bias, an organization should adopt internal controls to run standardized benchmarks for bias before selecting a model to use. These are test suites that measure the bias of the model by asking it various questions related to historically disadvantaged groups. Prompt injection is an attack where the model is given access to the internet or access to a document under an attacker's control, e.g. in your own intranet potentially, that takes control of the LLM and circumvents the safety controls implemented by the model provider as part of its fine-tuning process. If you want to avoid this issue, don't grant general access to the internet for the model and ensure that the model only interacts with documents from trusted sources. Data poisoning applies to training the model. If your organization is training its own models, you're already experts and you'll be experts in the goals to consider when forming your training set. There are hours of discussion on this point, but most organizations will not train their own models and instead have a provider or contracted expert to do the training for them. If acquiring a model from a vendor, ask what their data poisoning strategy for training data is. As long as they have a compelling process for weighting high quality sources and filtering out bad ones, this should be enough for most use cases. Finally, distillation attacks are a methodology for model theft. This attack concerns an adversary who has a weaker ML model and has an interest in stealing your model's capabilities. This may be a model you have developed or a model that you are using. For example, let's say you provide the best customer service agent in the industry. In this scenario, your competitor could write a bot to scrape your customer service bots for its prompts and responses to use as training data for their own model. A few thousand samples is enough to slightly lift the score on some benchmarks. A few million samples is enough to steal an entire capability. Rate limits and know your customer type controls are the only defense here. All right, so now that we've reviewed some of the areas of concern that organizations must consider when using AI, we can begin to discuss some resources that can be leveraged to help manage those concerns. In considering our own AI governance model, it'll be important to consider which regulations might flow down to an organization. For example, as a provider of large language models in the United States beyond a certain size, Anthropic has reporting requirements to the United States federal government under Executive Order 14110. For AI products serving citizens in the EU, providers must consider the EU AI Act, which holds organizations responsible for managing the risks of harm their AI product or service could cause. A few key points of the EU AI Act are noted in this slide and should be considered by an organization incorporating AI into its products and services. This act holds organizations accountable for understanding the level of risk their solutions pose and complying with proportional requirements. Organizations who are developing, deploying, or using AI can benefit from adopting ISO 42001 to create a complete AI management system. This new standard, aligned with the management systems proposed under ISO 27001, helps organizations establish policies and practices that define objectives, risks tolerances, support structures, and best practices for use of AI-enabled systems. ISO 42001 ensures that any regulations flowing down to your organization are considered in the design of your internal AI practices, that management is appropriately involved in executing governance, staffing resources, managing risk, ensuring compliances, and taking a measured and systematic approach. Using a framework such as 42001 helps set expectations for the organization about what is required to use AI safely and legally. And now I'd like to talk a little bit about how Anthropic is fulfilling its responsibilities as a model provider and how users of AI can leverage those capabilities to make their AI journey a little easier. As I mentioned before, I wanted to share about Anthropic's unique methodology for fine-tuning. Anthropic has discovered a new approach to AI safety that shapes the outputs of AI systems according to a set of principles. This approach is called constitutional AI because it gives an AI system a set of principles, i.e., a constitution, against which it can evaluate its own outputs. Constitutional AI enables AI systems to generate useful responses while also minimizing harm. This is important because existing techniques for training models to mirror human preferences face trade-offs between harmlessness and helplessness. Claude safety training uses AI-generated feedback based on the set of principles to choose the more harmless output. This becomes especially useful as LLMs rapidly scale and require increasingly large data sets for safety training. AI-generated processes like this can scale along with frontier AI model development. Other benefits of constitutional AI include its scalability and increased model transparency, benefits that become increasingly relevant as AI models continue to scale in their size and capabilities, making transparency vital to understanding model outputs. In Anthropic's testing, their constitutional AI model responded more appropriately to adversarial inputs while still producing helpful answers and not being evasive. The model received no human data on harmlessness, meaning all results on harmlessness came purely from AI supervision based on an explicit set of constitutional values. Selecting a model that takes a principled approach to fine-tuning measurably reduces many of the risks that we've discussed previously. But before selecting any model, users must do their own evaluation and testing. Take into account the time you'll need to research model capabilities and to run tests to determine how well the model serves the use cases for which you plan to deploy it. Organizations should review the published model cards for the models they are considering and understand which model benchmarks align to the use cases most relevant in their organization. Organizations should design their own suite of prompts that are intended to check for bias, misinformation, or inappropriate materials in the context of their use cases. Those tests should consider edge cases as well. But LLMs won't operate in isolation. Selecting the right large language model is just the beginning. Those models will be deployed in a much larger set of systems and will likely be augmented by data from other sources. Risks related to prompt injection and sensitive data exposure have additional manifestation opportunities in these extended architectures. So consider the plan for those architectures carefully. I encourage you to review the Cloud Security Alliance's research on authorization practices for LLM-backed systems. And finally, consider if you need additional fine-tuning to make a model better suited to your use cases. This can result in better results for specialized tasks, enhancing the performance of domain-specific actions such as classification or industry-specific data interpretation. Model tuning can also provide for faster speeds at lower costs, reducing the production operation of a model. You can have consistent and brand-aligned formatting of the model outputs, making it consistently structured and tailored to your exact specifications. It also can help make the model more safe and secure. Proprietary training data will remain within your environment as part of this fine-tuning process. All right, thank you so much for taking the time with me today. I hope this presentation provided a few useful insights for you and resources that you can rely on as you pursue your journey to ensure that AI safety is something present in the organizations that you serve. I've enjoyed being with you. I hope you take the time to enjoy the rest of this event today.